repeating decimals with one non-repeating digit. Have a look. Notice I have 0.4 and then 1 repeating. And notice, unlike my other repeating decimals that we've looked at, rather than being over 9 or 99 or 999, these two fractions are over 90. And so that might indicate to you, that's interesting. When something is over 90, that means it has a non-repeating digit and then a single repeating digit. So there's a trick to figuring out how you go from a repeating decimal with non-repeating digits and how you get that fraction. And here is that process. Let's pretend that we just want to find out what 0.35555 repeating is. So we're going to have, this is a certain process. This is called the conversion technique. And let's let x equal 0.35555 repeating. So if I want to call something 10x, then I would need to multiply 0.3555 repeating. I need to multiply that by 10. So that would move my decimal point 1 over. If I wanted to multiply it by 100, then 0.3555 repeating would go over 2 places. Now, why am I doing this? Well, if I have 35.55555 and so on, and I want to get rid of that repeating decimal, then I want to subtract 3.55555 and so on. So my repeatings will subtract from one another, and I'll just get a 33. Cool. But wait a second, hold on. How am I allowed to subtract those? Well, you have to realize that 35.5 repeating was 100x, and 3.5 repeating was 10x. So I'm going to subtract those. So 100x minus 10x is going to give me 90x. So 90x is equal to 33. If you know any algebra, if we try to isolate x is multiplied by 90, so to get rid of that, we have to divide, and that takes it away. And to do that, we have to be able to do it to both sides. This is an algebraic concept that some of you might know, some of you might not. If you don't understand it, just remember this. When you get 90x equals a 33, you need to take this 90 and put it in the denominator over here. So x is equal to 33 90ths. Now I have to simplify that, and I'll get 11 30ths. So if you plug into your calculator 11 divided by 30, you will get 0.3555 repeating. And so the trick is, for converting something, you need to multiply it by enough powers of 10 to just isolate the repeating part. So enough powers of 10 to just isolate the repeating part on the other side of the decimal. Then take the next higher power of 10 that will allow you to go through one of the repeating cycles. So notice I went past 3 and then through one of the repeating cycle, and in this case a repeating cycle was a 5. And so again, I have a different number, but still with the repeating decimal isolated on the other side of the decimal. That allows me to line up the decimal points and cancel like I did right here. And then I subtract that, I subtract these, and I do my division. So if I had 0.63333 repeating, I would let 100x be 63.333 repeating. 10x would be 6.333 repeating. I knew that because I knew for my larger value, I wanted to get past the 6 and then through one of the repeating decimal series. And then I just also wanted to just move the decimal, so I isolated just the repeating part. Now that's going to allow me to subtract, and then this 3/10 subtracts this 300ths, this 3,000ths, and so on, all negate one another. So 63 minus 6 will give me a 57, and I'll get 90x equals 57. And so now I'm going to get 57 90ths, and that is going to be my fraction. Now there's a trick, and I hope you guys will spend some time looking at 41. How does that become a 37? How does 56 become 51? How does 63 become 57? How does 31 become 28? Yes, 28. And notice all of these are over 90, which would be different. What is 0.3788888 repeating? That would not be over 90. That would be something different. And I'll let you explore that on your own. So that is called the conversion technique. And we will practice that a little bit more, but mostly I'd love for you to ponder this and figure out, okay, 56. How does 56 get to 51? How does 41 get to the 37? So 63 somehow becomes 57. 31 somehow becomes 28.